Now that the basic model's set up, I'm going to add to it. So in this task, I'll work on geoprocessing the data for the city boundaries, the roads, and the water features. I'll also clip the airports to Nueces County. So I'm going to start by opening up the graphical modeler. I can simply right-click on my helipad site selection tool, and instead of executing it, I'll choose Edit Model from the context menu. That opens up the model in the processing modeler. And I'm going to add a vector layer input for airports. So I'll double click on vector layer. The parameter name will be airports, LYR. The shape type is point, and it is required. I'll click OK. I'm going to drag this below my other inputs. Oops, grabbed the wrong object. There we go. And now I'm going to add a clip algorithm to clip the airports to the Nueces County layer. So I'm going to go to the Algorithms tab, expand QGIS Geo Algorithms, expand Vector Overlay, and double-click on Clip. The input layer is going to be airports, and the clip layer is going to be the output from the algorithm Extract by Attribute, which will be Nueces County. I'm going to leave the output blank since this is going to be an intermediate data set, and I'll click OK. And now I've got my clip algorithm. I need to start making my modeler window a little bit bigger so we can see the model as it grows. So now you can see the output from Extract by Attribute is being used to clip the airport layer. Now I'll work with the city boundaries. This is the most involved parameter because the site has to be both within 3 miles of Corpus Christi and beyond the Corpus Christi city limits. I'll add a vector layer input for the city boundaries. So I'm going to click on the Inputs tab, double click on Vector Layer. It's going to be called City Boundaries. LYR. Shape type is polygon, and it will be required. And I'm going to drag all my inputs so they get lined up along the left-hand side. Next, I'll need to do an extract by attribute on the city boundaries in order to extract the Corpus Christi boundary from it. So I'm going to need to add another table field attribute. So I'll double-click on that. This one is going to be called cityboundaries.attr. Not dot, just attr actually. The parent layer is going to be city boundaries LYR, and I'll click OK. Drag this below its parent. And now I'm going to add an extract by attributes, similar to how I extracted Nueces County from the counties layer. So I'm going to go to the Algorithms tab, to Vector Selection Tools, Extract by Attribute. Input layer is going to be the city boundaries. The selection attribute will be city boundaries ATTR. The operator is going to be equals, and the value is going to be Corpus Christi. And when putting these values in, they do have to match the text value that you're searching for in the attribute table. So you do need to look at the attribute table ahead of time to make sure what that value is that you're searching for. In this case, again, I've already done that ahead of time. I'm going to leave the output blank, and I'll click OK. So we have our second extract by attribute algorithm added to the model. The next step for processing this city boundary site selection parameter is to buffer the Corpus Christi layer by 3 miles. So I'm going to open up the vector geometry tools and find fixed distance buffer right here. So some of these algorithms will have slightly different names than you'll find in the toolbox. So it just takes some experience to find those. You can also use the search box at the top. So you could search for buffer and find this tool that way if you didn't know where it was. So here we're going to choose the input layer. It's going to be the output from the algorithm extract by attribute. And sometimes it's difficult to tell which one you're choosing from. These both end up having the same name here, but we're going to choose the second one because we've already worked with the first one. Now all of our data here is in UTM with coordinate units of meters. So we're going to buffer this by 3 miles, but we have to translate that into meters. So we're going to put the 3 mile equivalent in here. So it's 4828.03. So that, again, that's 3 miles in meters. We'll leave the default segments value of 5. We'll want to dissolve the result. We're going to leave the output vector blank and click OK. And you can always see if you've used the right input for this. So we are in fact buffering the correct one, the Corpus Christi city limits. The last parameter detail related to the boundary of Corpus Christi is that the airport needs to be located outside the city limits. So therefore, I need to take the 3-mile buffer output I just created and run a difference algorithm on it with the Corpus Christi output as the difference layer. This will take the buffer and erase from it the portion within the city limits, leaving a 3-mile ring around the city limits. So from the Algorithms tab, I'm going to go to the Vector Overlay Tools, scroll down, and find this difference algorithm. So the input is going to be that buffer output. The difference layer is going to be this second output extract by attribute, which is the Corpus Christi city limits. We're going to again leave the output blank, and we're going to click OK. So now you can see that the difference is taking this buffered output and taking the Corpus Christi city limits, and those are the two inputs to the difference. Now I'll work on the roads parameter. First, the county roads will have to be selected because our roads layer includes more than just county roads. Once those county roads have been pulled out and isolated, then those county roads will be buffered by 1 mile. So I'll add another vector layer input, switch back to the Inputs tab, double click on Vector Layer. I'll call this Roads, LYR. Shape type is line, and it is required. Again, I'll drag this down on the left-hand side to keep things organized. I'm going to need a table field input to select out the county roads. So this will be Roads, ATTR. Parent layer is Roads. And I'll drag this table field input below its parent. And now I need a third extract by attribute to pull out those county roads. So I'll find that tool. The input layer is going to be the Roads layer. The selection attribute is going to be Roads, ATTR. And you'll see it's smart enough to be able to identify the table field inputs that we have in the model. We'll choose the Roads one. The operator is going to be equal, and the value is going to be C. There's a column in the roads of type, and county roads have a value of C. I'll leave the output blank and click OK. And here's our third extract by attributes, creating the county routes. And now we're going to need to buffer those. So I'll go back to my geometry tools and find this fixed distance buffer. Input layer is going to be the third output from extract by attribute. And just like we did with the Corpus Christi city limits, we're buffering these by a mile, but we're translating that into meters. So the value is 1609.34. We'll leave the same default segments value. We'll dissolve the result, leave the output blank because it's another intermediate data set, and click OK. Oh, see, it looks here like I chose the wrong extract by attribute, but that's not hard to fix. I'll just click the Edit button on this and choose a different one. It should be the correct one. Okay, there we go. So now it's connected to the correct input. The last parameter to address is the water features, which have to be buffered by a ½ mile. So it's really one of the easier things to deal with. We've done the most difficult parts. I'm going to add another vector layer input. Call this water. Shape type is line, and it is again required. Drag this down to the bottom of our model. Go back to the Algorithms tab and find the Fixed Distance Buffer tool. Again, the input will be the water layer. And here again, we'll put in the meters equivalent of ½ mile, which is 804.67. We'll take the rest of the defaults and click OK. So there's our buffer for water features. So we've done the vast majority of the model here, and it only took a few minutes. You can see you can string together quite a few operations fairly quickly. And again, we'll be able to run all of this as one operation. So it's going to be a very efficient way to run this analysis. In the final task, I'll combine all these individual parameters into one layer representing the combination of all parameters. This will represent the acceptable area for helipad locations. And then I'll use a clip operation to pull out that final airport that is the solution.